Hey everyone, my name is Smriti, and today I'll be walking through question 4 on the week 9 worksheet, hashing practice. So today, for part A and B, we'll be kind of simulating how to insert into a hash map and essentially how insertion works with the buckets that we hashed by. So here we see that our hash code, it says in the problem that the integer hash code just returns the integer's value. So this means that in a hash map, the value that we have for our integer at the key is just going to be our hash code. So all of these values, let me change my color here, are going to be our hash codes. Cool. So when we're inserting, we can't just insert based on our hash code. We have to do a little bit of manipulation to determine which bucket it's going to go into. And so in order to determine that, we're going to mod our hash code by the number of buckets. So what this formula essentially does is after we get our number, which is our hash code, we're going to know which bucket to insert into because like if your hash code is by chance bigger than the number of buckets here, which is 5, you'll still be able to insert into a bucket. You might just have to repeat or add more elements into one bucket. So we'll see how that works when we actually go through this problem. The first one is asking us to put 3. So at the key 3, we want to put the value monument. And so 3 mod, so there are 5 buckets here, 0, 1, 2, 3, 4. So number of buckets is equal to 5. Cool. So here our hash code will be 3 because it says that the hash code just returns the integer's value. And so 3 mod 5 is going to be 3. And so we're going to insert into our third bucket right here, monument. So I'm going to, since this is a hash map, it has both a key and a value. And so I'm going to show that I'm inserting both of those. So this is my key and this is going to be my value. So 3 and then, oh no, that's quite a big word. Let me try to fit it in here. All right. So let's move on to the next one, which is 8 enshrine. So 8 mod 5 is also 3. And so when we, this actually brings up a good point. So when you want to insert more than one element into the same bucket, since we're using an externally chained hash map, it essentially ends up looking more like a linked list where we keep chaining on to the end of whatever's already in that bucket. And so here, shrine will just be added after our 3 and monument. So this will be connected to our next key value pair, which is 8 and shrine. Solid. And then for our next value, which is also 3, or our next key, sorry, that's also 3. We want to mod that by 5. We're going to get 3, so we want to insert into the third bucket. So this actually brings up an interesting point. A lot of people will actually, at first, add it to the end like this and say, okay, I'm just going to insert another thing with the key 3 and the value worker. And this is like intuitively, it makes sense, right? Because they are different values, like monument is different from worker, so you should be able to insert both. Unfortunately, this doesn't work because you can't actually map the same key, which is 3, to 2 different values in a hash map. Let me write value. So yeah, this won't work. Like if you want to put worker and monument. And the main reason why this doesn't work is because let's say you call the hash maps get method, right? And you want to get the value at key 3. If you have 2 values stored at key 3, your computer or your program is not going to know which value to retrieve. And so it might be luck of the draw, which one you get. But that's not going to work because that introduces randomization. And so that's why the structure essentially doesn't work. And so for every key, you can only have 1 value. You're not allowed to have 2 values for a key. And so what does a hash map actually do in this case where you are trying to insert a new value at the same key? It's actually going to overwrite what you had in your old one. So here what it's going to do, instead of adding this, this link at the end that I've written in red, it's actually going to just overwrite monument with the value worker. Solid. Okay, let's move on. We're going to insert granary at 5. And so 5 mod 5 is 0. So I'm going to put it at the 0th bucket with a key of 5 and the value of granary. Cool. And the last one is 13 and worker. So 13 mod 5 is also 3. And so what I'm going to do is I'm just going to add it to the end of this very long chain here. 13 and worker. And so now you might be asking, why is this allowed? Like, why am I allowed to add? So like worker is the same. Like I see another worker here. Why am I allowed to have the same value? It's because even if you have the same value in like multiple keys, that's okay because you can still access them properly. So if you call 13, you'll get worker. And if you call, like if you try to get the value at 3, you'll also get worker. But that doesn't matter because they're both like strings. They just happen to be the same string. And so that's fine. The only issue is when you have one key that's mapping to 2 different values. Cool. Let's move on to this part B. So I'm going to erase what I have here so that I have more room. Cool. In this part, it's saying a resize occurs, doubling the array to size 10. And so now you have 5 more buckets available to you, which you can insert into, and it asks what changes. The main thing I want to kind of highlight here is our formula for determining where to insert. So here, our number of buckets was 5 in the previous example, but now our number of buckets is going to be 10. And so our hash code is now going to be modded by 10 instead of 5. And that's where most of our changes are going to occur. And so here, let's just go through the motion again of modding. So 3 mod 10 is equal to 3. And so I'm going to insert monument into my 3rd bucket. Cool. And then let's look at 8 mod 10, which is 8. So previously, it was when it was modded by 5, we had to insert into the 3rd bucket. But here we can just insert into our 8th bucket because we have one. And so I'm going to insert the value at 8, which I think was shrine. Cool. And then our next one is 3 and worker. So we're going to insert, it's going to do the same thing that we did before. It's going to overwrite the monument value that we have here with worker because we're trying to insert 2 different values at the same key. And then we have 5 and granary. So instead of putting it at the 0th bucket, we're actually just going to put it at the 5th bucket here. So 5. Cool. And then 13 mod 10 actually ends up also being 3. So we're going to insert our worker here. And it's okay that we have 2 workers at different keys because they are both unique strings. Cool. So the main differences that I see between the two, like the 2 parts, A and B, is that our chain of elements is shorter in part B. So with the resize, we're actually able to distribute our elements better throughout all the buckets. And this essentially ensures that we can find each element at a faster time. And so an optimal hash code will actually distribute all of the values among the buckets without having to chain. And that's why we can get an order of 1 runtime when inserting and retrieving from a hash map. But it all depends on the hash code. And so here we can see that the resize, essentially allowed us to distribute our values among the buckets better. Cool. So if you have any questions about this problem, make sure to reach out to your mentors and ask them for help. I will see you guys at the next walkthrough.